Hi everybody. Today we'll be talking how 5G as an enabling technology can help us in building smart ports or harbor cities. Malaysia being one of the growing economies in the region and an international trade center where imports, exports and transshipments of commodities and goods are being transported in and out of the country every single day by using seaports and are considered one of the most important logistics centers as more than 80% of the worldwide freight is transported this way. As we now live in a modern world where technology is the key to survival in any trade and industry, the key to survival for Malaysian seaports is to transform and convert our ports to become smart ports, where the technology takes the central stage in seaports and terminal operations, where our ports function in an automated manner and uses technology like big data, Internet of Things IoT, blockchain solution and other smart technology or IT platform-based methods to improve performance and create efficiency to actually achieve economic competitiveness. Now 5G is the 5th generation of wireless cellular technology where it has been greatly increased in terms of speed and responsiveness of wireless network compared to its predecessors like 4G and 3G. To show the enormous difference between 5G and its predecessors, let us compare them in a few ways. 5G is much faster compared to 4G, as 5G travels in an extremely high frequency, which is known as millimeter wave, which allows transmission between 30 GHz and 300 GHz compared to 4G, which typically transmit between 800 MHz to 3000 MHz, which allows 5G to transfer data 10 times faster compared to 4G, as it is less congested. 5G also has a much larger bandwidth compared to 4G, which allows more amounts of data to be transmitted in a given time and avoid congestion. 5G also has much lower latency compared to 4G, with 5G only 10 milliseconds of latency compared to 4G's 40 to 50 milliseconds of latency, which makes 5G 4 to 5 times faster than 4G. Although 5G has a much shorter coverage compared to 4G, ports can implement small cells to counter this, as small cells are able to extend the coverage and increase the network capacity. It is also more beneficial to use small cell compared to other alternatives, as it only requires minimal power to operate and has a much lower cost compared to its alternatives. Now imagine if a port does not utilize 5G and sends a large amount of data at once. This will cause congestion throughout the network, as there is not enough bandwidth for the data to be transmitted at once, which will cause queuing delay and packet loss, which will disrupt the network and data and slow the service and even cause total loss of network connectivity, which can hugely disrupt the efficiency and safety of the port and cause total chaos. So in conclusion, 5G provides higher bandwidth and speed and lower latency compared to 4G. Data will be transferred at much faster and more consistent rates, which will help in improving the efficiency of the port and better allow real-time operations like detecting malfunctions as soon as it appears and monitoring situation and making changes if necessary. Another characteristic that 5G can bring to the table in helping in building smart ports is network slicing. Network slicing allows multiple logical networks to run at the same time on top of a shared physical network infrastructure. Operators can effectively manage diverse 5G use cases with differing throughput, latency, and availability demands by partitioning network resources to multiple user tenants. So the cost, resources management, and flexibility of the port network configurations can all be optimized to help in reducing costs and allow greater efficiency. Network slicing can be implemented using two different concepts, using software-defined networking (SDN) and network function virtualization NFV. It will help to implement flexible and scalable network slices on top of a common network infrastructure. SDN enables the network to be intelligently and centrally controlled using software application, which helps in managing the entire network consistently regardless of the network technology. But for NFV, it separates the software from hardware by replacing various network functions such as firewall, load balancer, and router with virtualized instances running as software. This eliminates the need to invest in many expensive hardware elements, which helps in saving costs for the C-ports so that it can invest in other areas. As these network slices can be changed and have their own different characteristics to meet specified requirements, they can help in smart ports where they might be used for an emergency service during a storm surge, like where they were used in the port of Hamburg, where they will use different network requirements to actually fulfill the different objectives. For example, using sensor to allow real-time monitoring and analysis of motion and environmental data from large parts of the port area, and using 3D information to actually call out additional information such as building data or receive remote interactive support from an expert using the 3D glasses. Another use of the network slicing is to better help in the traffic flow by using the Intelligent Transport System (ITS). This can be done by connecting the surrounding traffic light near the ports to the port center road traffic control management by using 5G mobile network by using another dedicated network slice. This allows the surrounding traffic can be easily controlled to help in efficiently delivering goods on time and prevent mischiefs from happening. All in all, network slicing will actually help ports in saving costs to actually help them invest in other areas, as well as help in the efficiency of the ports by being able to control numerous other factors.
Due to the need for intensive automation in smart ports, the use of device-to-device communication on scales previously impossible for 4G networks are necessary. Device-to-device refers to the ability for equipment to communicate directly with other equipments with or without partial involvement of network infrastructure. 5G can allow for equipment to communicate more effectively as it is entirely unreliant on wave-based station technologies, and as such is able to provide reliable links with high data rates and instantaneous communication and quick file sharing. One of the most effective methods to implement device-to-device communication lies in the use of cloud vehicle-to-everything communication. Through this, autonomous vehicles in the smart port can be connected to a 5G cloud, enabling them to exchange information with other devices within the network in real time. This infrastructure is also easily self-scalable, as devices can be connected to the network as soon as it enters its range. As such, we can conclude that with 5G's ultra-low latency, high bandwidth, and network reliability capabilities, Level 5 autonomy in vehicles may not just be a pipe dream. The system's incredibly high throughput and reduced latency speeds up the exchange of raw and processed data shared throughout the vehicle network, greatly reducing the chance for any major congestion. Frequency division multiplexing is also utilized for resource multiplexing across vehicles, as this will allow for larger link budget, accommodating the large amount of traffic commonly seen in ports.